Hello everyone, welcome to another video of DSA Bootcamp with GDSC GHRCE. I am Sanika Peshkar and today I'll be covering is the create, insert and delete operations on linked list. In the past video, you might have seen what linked lists are, how nodes in the linked list are stored, the elements of a node in a linked list, and how linked lists are in a way better or not better than arrays. When we learned about arrays, we did see as in the elements of an array are stored at continuous memory locations. That made it easy for us to access the elements, but we needed a continuous block of memory in the memory for the array to be stored. That made it a bit complex, but while accessing the elements of an array, you needn't always keep a track of every element. You could directly access it by knowing its index number. Like if you write array of 1, it would eventually give you the element 3 over here. But it is not the same in the linked list. As you have seen, linked list could be similar to a treasure hunt game. Like in a treasure hunt game, how you got a chit in your hand and every chit used to point out to a next chit or used to store the address of where the next chit is. The chit used to have some clue that would point out to the next chit, and the final chit would point out to nothing, that is null. Similarly, the link in the linked list, head stores the first element, and every node or every chit would point out to the next node, which would store a value and the address of the next chit. And this way the linked list are stored. That is, the elements in the linked list or the nodes in the linked list aren't stored at continuous memory locations. They don't need a continuous block of memory to be stored. You could store random chits at random locations and find it using the clue given on them. That is, find it using the next address given on them. So we'll be seeing that in detail while we code, but let's first take a look on how the structure of every node looks. So here, while creating a node, we'll be using a user-defined data type, that is class, and every class would have two properties. That is, it would have two elements. It would have the data or the value for which it is made. Like every address should have something to be stored in it, right? And the address of the next chit or the next node, as I say. So in the linked list, we keep a track of head. Head is the first element or the first chit which is handed over to you in a game, and through head we traverse through the linked list. As I said, in arrays we used to have indices and we used to access the elements using those index number, but here in linked list you don't have the index number, as every node is stored at a random location and you cannot keep a track of every node's address. So rather than keeping a track of every node's address, we give the address of the next node in the previous one, so that when we get to the previous node, we could easily access where the next element was. But like in arrays, it was easy at those were continuous memory locations, and like if the data type int is of 2 bytes, we could directly add on 2 in the address, and the next element would be at the address 2 bytes after. But here it is random locations and keeping a track of them is quite difficult. So rather than keeping a track of every memory location, we keep the next address stored in the previous one, and we just keep a track where the head is, and we keep moving on head and traverse through the linked list. And finally, how would we know as in when we reach the last element? So here the last element stores points out to null. So to check if we have reached the last element or not, we would be like checking if the address of the element. If it points out to null, then that is the last element and there our linked list ends. So we won't be traversing any further. So this was all about how nodes are in linked list. We'll be seeing as in how insertion, deletion operations are performed on linked list, and let's try and code it. As in now, when we know what a node contains, we would try creating a node and performing insertion and deletion operations on a node in a linked list using certain functions. And let's try creating this linked list over here. So for that, I have declared the head and the first variable over here, initialized them to null for as of now, and to allocate a memory space to these nodes, as it is a class, and we have to allocate a memory space in a heap. So I have used over here the new keyword. It is similar to that of a calloc or a malloc you might have learned in C. And let's store some values in it. So for now, to create this linked list, the first value over here, the head would be 1. So we would store head ka data to be 1, and head ka next pointer we will point out to first. So I have done that, and for first we would store, let it be 3, and okay, sorry, first ka data it should be 3, and first ka next pointer it would be second. So we haven't declared second over here, so let me do that first. We would be using the insert and delete functions too, but before that let me show you this way. So let's first try printing these. To print these, I will write a function print, and as you know, we traverse in a linked list using the head pointer. We would take head as an argument, and to secure our head we would store the head pointer in a temp variable, and we would traverse through the head until we reach the last point. So our last point is when head is equal to null. We would print head ka data, and for it to look good, I'll use an arrow over here. And once we are done, once we reach the end of the linked list, we would print null over here. So let's try printing this. I'll pass head through this. And one more thing we forget, that we have secured head in this temp variable, but we need to restore the head back so that we could use it further, or our head would remain at the last position. So we did restore it, and let's try print it. Okay, this is going endlessly because I didn't do, or I didn't increment the value of head, so it would go as in head is equal to head ka next. So every time I need to increment the value of it so that it would reach the last position, or it would print endlessly until and unless it reaches null. So let's try and run it again and see. We did insert the first element to be 1 here, the second was 3, and we have reached the end of the linked list. As I haven't inserted these elements yet, so this is the end of our linked list. Okay, so now when you have created this linked list, to create this one you need to perform certain insertion and deletion operations on the linked list, which we would be coding now. And there are three types of insertion functions you could perform on a linked list. That is, either you could insert a node after some node, like after 1 you could insert 2. You could insert a node before some node, or you could insert a node at end. So we would be seeing these all one after the other. So let's start with insert after. To code it, let's create a function of void return type, and we should know the previous node to insert after certain node. So we would take the previous node and the value which is to be inserted after a node. For that, we would allocate a new memory space for a new node, and after that we would check if our previous node is null. That is, if our previous node is null, we are trying to insert at a wrong position, or we are trying to insert after the linked list has ended. So we would print that this is the wrong position or cannot be inserted. Else we would store new node ka data to be the value which we want to store, and we would store new node ka next to be previous node ka next. That is, our previous node ka next was 3. That is, 3 should be the next node for our present node. That is, this 3 should be the next node for our present node. The 3 is previous node ka next, which should be new node ka next. That is what we are doing over here. And okay. And after that, we would just store previous node ka next to be our new node. So we have created the insert after function. Let's try to insert 2 after 1. So 1 is our head for now, and we have to insert 2. So to print this, I have to pass head. Okay, let's try and run this. Okay, see, we have inserted 2 now in between 1 and 3, and previously our linked list was this. Now we are done with insert after function, and now we are left with 2 other insert functions that we would code. That is, insert before. That is, if you want a node, say 2, to be before the head, then how would you insert a node before head? Or another one is insert at end. That is, if you want to insert a node after the last node, or for here our last node is 3, so after 3 if you want to insert a node, how would you insert it? So let's try to code these two functions. So for that, I would again write a function insert before over here. I'll take node, or I'll take head and the value to be inserted. After that, I'll create a new node first. And once I have created the new node, I know that new node ka data would be the value, and new node is to be inserted before head, so new node ka next would be head. Like here, if I insert a value over here, I know new node ka next would be head. Our head is 1 now, and after that our new head would be now new node, so I have to store the new node in head. We'll try printing this, but before that we would also write a function to insert an element at the end. To insert at end, I'll create this also of a void type. I'll need head again and the value to be inserted. Now our end is 3 for now, and we have to insert 4 and 5 after that. Let it be 4 and 5. So for that again I'll create a new node in a similar way, and I'll store my head in the last node. Okay, I don't know where the slash came from, and node ka data would be our value, and new node ka next would be obviously null. As we know, it is to be entered at the end. So we'll check if our head is equal to null. That is, if no values are present in the list or linked list, we would directly make head, or we would directly store the new node value in head and return. Okay, this is a void type, so we need a return. Or else, what we would do is, we would traverse to the end of the linked list using the last, as our last stores the head value. We would traverse through the linked list, and we would store to store the value of the end, we would check if last ka next is null. If last ka next is null, we would know that this is our last node. So until and unless last ka next is not null, we would traverse, and once we reach the last of the linked list, we would store last ka next to be our new node. So that's it. Let's try printing these two. So insert before, let's insert 2 only over there, 2 before head, and print this one. Okay, see, we have inserted 2 before 1 now, and we did use one more thing, that was insert at end, and for that we needed the head and whatever we need to insert. So let's complete our linked list which we wanted to, and after head we wanted 5 too. So see, we have inserted 2 before the head value. We did shift our head to 2, and now we have inserted 4 and 5 after this 3. So this linked list looks similar to that we wanted to create, but we would use deletion operations and you would reach this linked list afterwards. So now once we are done with insertion operations, let's try deleting and let's try reaching this linked list. So for deletion also you have two types of deletion operations. That is, if you want to delete a node at the head position or just delete any one node. So delete at head is used for corner conditions, that and delete is used to delete any node in between. So let's try and code these. So before print I'll be adding another function. Let's first delete the head node. That is, for now our head node is here 2. To delete the head node, we'll write delete head. Again we'll need the head position, and to delete we don't need a value. So to delete, we would create a delete variable that would store the node to be deleted, and for head we would shift the head to the next, so that once the head is deleted we have the actual value of head. And now we will be using this new delete keyword over here. So this would eventually free our memory space. Like we here use the new keyword to allocate a memory, and delete over here is used to deallocate a memory. So let's try deleting our head. For now our head is 2, and let's try printing after our head is deleted. So see, this was our linked list before, and after deleting our head we got this linked list. So now I would insert at end 6, and we would delete this 6, or let me insert after head another value, that is 4, and we would try deleting this 4. So let me first print this to show you how this looks. And see, we have to delete this 4 which is here in between, and after deleting this 4 we would get the linked list we aspire to get from the beginning. And let's start. So I'll delete this print, no, let it be. So for delete I'll write another function, as this is not of a corner condition. Okay, delete is a keyword, so I should write it this way, and I would need a head and the value to be deleted. So here I know I want to delete 4, so I'll check if my head is equal to null. That is, if no values are present in a linked list, what would I delete? I would simply return, or else I'll store the value in a temp variable, my head in a temp variable, and traverse to the value which I want to delete. So to traverse to the value which I want to delete, I'll use a loop over here, and until and unless my temp ka next ka data, I have to reach the previous node. I cannot reach that node, as I cannot come back in a linked list. So until unless my head का next का data is not equal to, okay, sorry, it shouldn't be null. I have to check here for value, and until unless that isn't equal to value, I have to keep incrementing my temp equal to temp ka next. So once I reach that value, I would store delete to be, I would store the value which is to be deleted in a delete node, and I would store temp ka next to be temp ka next, as beach ka node would be gayab, no? So after that, I would simply deallocate a memory, and this is it. So let's try deleting. Our function name was del, no? Del, yeah. So what I need is, I need head and I need the value 4 to be deleted. So okay, I didn't print it. So see over here, R4 is deleted. Let me make it a bit clear. Okay, so you can see over here we have got the linked list we wanted. We have deleted this 4 from here. So this was all about insertion and deletion in a linked list. See you all in the next video. Like, share and subscribe to GDSC GHRC and keep practicing. Thank you.